Yo, what's up guys, welcome back to another video, and this video is gonna be very special for this series, and today we are gonna take a step towards the actual program. Now you might have seen any kind of manuals or videos regarding CNC programs, and trust me, even I found them tough in the first look, didn't you? But in reality it is not. Anyways, leaving everything back, in this video we are gonna discuss about what CNC programs are, why are they extremely easy to learn, and how can you. So let's find these answers again after that famous and boring dialogue that every YouTuber does.
If you haven't seen the last video, see it first, and then come for this one.
So here we go. If we go for the shortest way, CNC programming is just to program toolpaths. Whatever it may be, it could be CNC lathe, milling or plasma. Every CNC programming is programming toolpath. And you must know what is toolpath. Actually, not only toolpath, but making coolant on or off, changing tool, making doors close is also the part of CNC programming. Now, without any distraction, let's just jump into it. So what do you think? What machine will do to make itself work on the exact way we want?
It will navigate using Google Maps?
Not exactly.
What you mean by exactly?
Navigate is okay, but not using Google Maps. Actually, it uses the standard lines, or we can say checkpoints, to navigate its position, just like we consider those standard hypothetical lines drawn around Earth.
Are you talking about the geometrical axes being used for graphs?
Exactly. I am. Thank you. I am talking about the axes and that point plotting concept we did in our earlier high school classes. This machine will just consider a hypothetical plane right here with two axes in case of CNC lathe, and it's standard actually. For lathe, this which is in outward direction, for diameter is x-axis and length is z-axis, so this is xz plane. Now moving to the program, suppose I want to perform pressing operation on this workpiece using CNC lathe. Then first thing I will do is imagine some toolpath with considering required parameters. Suppose for this case, this is main interface of machine with the center point of workpiece at origin of axis and tool already positioned on the edge of the workpiece. And yeah, we don't actually keep tool on this position in reality, but consider for this time only. That's it. Now let me just explain what should be the tool path. I will just make my tool move this side up to the depth of cut. Suppose it is 1 mm. Now I will just say to the machine, hey CNC, I want you to move 1 mm on this axis, which is Z axis. Subsequently, I will wish to move to the center of workpiece while cutting with some feed rate. Now just say it. Hey CNC, I want you to move to the center of workpiece with feed rate of say 1 mm per revolution. Then make tool retract. Move outside the workpiece to avoid it from scratching on workpiece. And they go somewhere else. Or we can say go to hell, home. So say it. Hey CNC, I want you to move outside in the Z axis and then go to the home position. And that's it. You just commanded a toolpath for performing this fixing operation on CNC lathe.
This doesn't look like a program.
Did I say program? No, I said command. These are just commands.
I don't think it's gonna work.
Will you please be patient and let me explain? Okay. Now here's the twist. These commands are made by me, but not everyone will do it in the exact way. Someone may not like to say hey CNC every time, or maybe someone will like to create a name for its CNC like a pet, or someone smarter will try some coding to make command a bit shorter. At last, I just wanna say these commands are not a standard code, because this will definitely change with change in place and person. More specifically, we need to make these commands to look like a NC code and apply specific methods to process of programming. I just wanna say there is a standard way like every other programming language to express your command. And by using that method, everybody's program for the same toolpath will look exactly the same. So let's just start editing these commands to the program. First thing, we don't need that hey CNC I want you to every time. So we can just delete that thing. Then we know machine uses those axes stuff for navigation. So we can just define that path using those quantities printed on axis. So for this workpiece, if I consider diameter as 40 mm, then this point, which is start point in fact, must be 40 on X and 0 on Z. Now I'm just gonna plot those points of tool path and just type them in front of the respective command. So second point is 40 on X and -1 on Z axis. Similarly, third one is 0 on X axis and -1 on Z axis. Again for retraction, 0 on X and 0 on Z. and then home position. Now just observe the commands. Here 1 mm on Z axis is this point in fact, then the center of workpiece is this, and similarly outside on Z axis is this one. So we can just erase this text and type those points instead, which are more obvious, and that's now looking like a program, isn't it? Okay, it is looking like a program, but it is not a program up till now. Because these are just general knowledge skills to standardize our command. But suppose there is a big program, then here terms like move, feed rate, change tool, these terms just get irritating by using over and over again. So someone needs to take care about that too. And for that, someone smarter created some standard codes which are raised with names G and M code. Yeah, I'm finally on the right track. Because these codes does the great job while avoiding these same terms getting in program again and again. Because some of them like feed rate and spindle speed are just compressed to their initials and we can use them all whenever needed. Suppose for our case here we can replace this feed rate word by just F letter. And what about this move? Here we can use G codes and as they are standard, I just need to Google them. I'm serious, just Google it. Or I will leave a link in the description for the start of G code. Coming back to the topic, we want a code for move in straight line. And we got them. Here G00 and G01 are a bit similar codes because both are related to movement in straight line with the only difference of using feed rate. Because it's obvious, whenever you are moving tool for cutting purpose, then you will need to give a proper feed rate. But what if you are not cutting? Because typing feed rate for moving machine in space with rapid motion, that doesn't make any sense. In short, the difference is that G01 moves with feed rate and G00 moves with rapid, which is the fastest your machine can go. So let me just insert them. Here for first line, I will be moving machine in rapid, hence using G0. Then here is cutting motion and feed rate is also there. So yeah, you guessed it. Here is G01. Here G00 as well. And for getting to the home position, actually there is a specific code as well. Just scroll down a little bit and here you can find G28 return to the home position. Now machine will go to this position after completing phase. And if I insert G28 on the start of program either, it will look awesome. I mean starting and ending at the same point. Looking perfect cycle, isn't it? And speaking frankly, you should read all the G codes for a single time. And M codes are there as well. Just read them once even if you don't understand. But it will definitely help you to find exact code you want when you will program next time. And I suggest you should go for the list given in the description below because
it's made by you and you need to advertise yourself.
no, because G codes are not only used for CNC lathes but for other CNC machines also. And when you try to Google them, you will find all G codes, but you don't need them actually. You need codes for lathe only, and that's what I have listed in the list given in the description. And yeah, there is a PDF file linked in the description too. Just open it, you will find these points listed there. So what you have to do is take a graph paper or mark X and Z axis on a blank paper and join these points after plotting them. Suppose in this case, here are 3 points. If I plot them on paper and draw a line with its original sequence, I get this shape. So just plot that list by your own and tell me in comment section below what is the shape it takes. Just for fun. Comment me. I'm serious. Just do it. And I am talking this because we are done with this program. Yeah. Now if you run this program on actual CNC or in simulator, then what the CNC will do is it will just crash because your spindle isn't running. And yeah, you will need to program it as well. In fact, we need to program tool number from your tool turret, spindle speed, coolant on off and its spindle direction as well. But don't worry about, they all have a dedicated code for them. Just scroll down a little bit and here you will find G96 for constant surface speed, or we can say constant cutting speed. Again scroll down a bit more in M code. Here M03 and M04 are used to make spindle on in different directions. As shown, M03 for clockwise and M04 for anti-clockwise direction. And just below it, here's M06 for changing tools. So let's just insert them too. And don't worry about syntax, it is there in the table. At start, G96 cutting speed suppose 500, M03 for spindle on, then tool number 1 with M6, and that's it. Now your program is completely done and now it's time for bye-bye. So these were some of the concepts that you could be able to learn at first days of your programming. and you will be watching more bigger programs in upcoming videos, so stay tuned. And I can just hope that you did understand all those concepts in this video, and if you didn't, then just watch the video again. Or you can comment me about any minor upgrade in my way of telling. And then I think you can at least do subscribe and let your friends know about this series. Hey Watchman, it's your dialogue.
Yeah? I am not a watchman.
Not that.
So? Which one?
You had a script.
Yeah? Subscribe to the workshop, guys.
To be continued.